Good day, class. This is part 2 of our discussion on the topic of projectile motion. But this time, our attention is on projectile motion launched at an angle or projectile launched non-horizontally. Here are the learning objectives. Describe projectile motion launched at an angle qualitatively and solve problems related to projectile motion launched at an angle. Now, let's have this scenario. In order for us to understand non-horizontally launched projectiles, wherein a cannonball or a cannon rather is aimed upward and shot at an angle to the horizontal at this very high clip. So let's imagine that gravity is turned off. Automatically, the cannonball would travel along a straight line inertial path, as you've noticed here in this illustration. Again, this particular path is what we call inertial path. This shows again the concept of the law of inertia. Okay, and it says there that an object in motion would continue in motion, as you notice here, at a constant speed in the same direction if there is no unbalanced force. Since in reality, gravity is present, so the cannonball would once more free fall below this straight line, this gravity or gravity free path or inertial path. In fact, the cannonball travel in a parabolic trajectory. Okay, so this is due to the influence of gravity. So again, the downward force of gravity would act upon the cannonball to cause the same vertical motion as before a downward acceleration. So the cannonball falls the same amount of distance every second as it did when it was merely dropped from rest. So once more, the presence of gravity does not affect the horizontal motion of the projectile as what I discussed last time in our previous video recorded discussion. So the projectile still moves the same horizontal distance in each second of travel as it did when the gravity switch was turned off. Always remember that. The force of gravity is a vertical force and does not affect horizontal motion. So perpendicular components of motion are independent of each other. So you would notice some of concepts are similar with what I discussed from horizontally launched projectile in terms of inertial path and the parabolic trajectory. So again, this is your non-horizontally launched projectiles in terms of its motion if we're going to describe it qualitatively. So putting all together, non-horizontally launched projectiles are objects that are thrown from the ground at a certain angle. Concerning the horizontal component, the motion of the object is considered projectile at an angle. So that's the reason why we call it projectile at an angle or non-horizontally launched projectiles. So this is a typical diagram of a projectile at an angle. So you would see that there are variables here. So V sub OY means the initial, but we keep on using the variable V sub IY. So that is for initial velocity at the Y component, okay? Or in your vertical component. So Y means Y-axis for vertical component. if you've noticed, v sub ix, that is initial velocity at the horizontal components. So the v sub o here, what we keep on using is the v sub I, that means initial velocity. Okay, so v sub y here means the final velocity. V sub x means the final velocity at the horizontal component or horizontal axis or the x-axis. Okay, so wag malilito with these letters. But again, all of these are referring to your velocities. Okay, so there's an angle involved, kaya siya projectile at an angle. So it varies depending on the given angle in a certain problem. So the trajectory here, the broken line here is the trajectory. This means that the path followed by a projectile flying or an object moving under the action of given forces. So that is the meaning of your trajectory. So another thing that you have to be mindful of with regards this illustration is the maximum height. We denote it as h max, or in other physics books, d sub y. So distance at y component, or your h max, or the maximum height, that is the highest vertical position along its trajectory. So that's how we describe or define your maximum height, or your d sub y. Again, the highest vertical position along its trajectory. Another thing that you notice here is the x sub max, or in other physics books, d sub x. This is just the same with the term range. Okay? The range is the distance between the launch point and the point where the projectile hits the ground. Okay? So again, from the point of release to the point where the projectile hits the ground. So that is your range. So we have velocities involved here, trajectory. Okay, velocities could be your vertical or your horizontal velocities. You have the maximum height, you have the initial velocity, you have the range, or your d sub x. So again, this is the typical illustration of how we visualize projectiles at an angle. So here are the equations to be used for projectiles at an angle. So no need for me to explain some of the equations here. Parehas lang din yan. Nagkakatalo lang sila sa variables, no? D sub y, D sub iy. Okay, so v sub y, as what I mentioned earlier, if there's letter I, okay, in the variable, that means initial. If there's none, that means for final. Okay? Okay. Now, make sure that you screenshot this particular slide para you can go back to this particular slide once we solve problems na related to projectiles at an angle. So, same technique. We are to analyze, illustrate the problem, utilize the GRESA method. We are going to identify the given, no, in each of the problem, and determine the best formula to be employed to solve the unknown. Now, here's the thing. You have to review your mathematical concepts, your discussion about trigonometric functions. Okay, lalo na yung first three trigonometric functions, your SOHCAHTOA, okay, for your sine, cosine, and your tangent. Okay, but nothing to worry, I have prepared a video recorded discussion for trigonometric functions and how we can use that in physics subject. So I'll provide the link in the description box below. Okay, so you have to look on that video recorded discussion in order for you to perfectly understand some of the equations here, especially this equation and this equation. So you would see that there's sine and cosine involved here. So hopefully you check on that particular video recorded discussion. But again, nothing to worry. I'll discuss these equations as we move forward to the given sample problems. Since SOHCAHTOA, these first three trigonometric functions are important in this concept, no? Yung projectiles at an angle. I will further elaborate it. Okay? So hopefully napanood niyo yung video recorded discussion ko for this particular topic. So in most cases, we're dealing with objects thrown at a certain angle. So let's say the arrow is the one that represent your object thrown at a certain angle. Okay? So there's an angle involved here, and the symbol for angle is the theta symbol. So theta is just, or it refers to your angle. So again, the arrow is for the object being launched at an angle, at a certain angle. So using this one, objects that are launched at a certain angle in this particular projectile has initial velocity. So the variable that we use for that is the v sub I. Okay. Now, since we're after getting the vertical velocity, okay, as well as the horizontal velocity, okay, so we're using concept of trigonometric function here. Okay, and we're going to further create here a right triangle. So the longest part or longest side of this right triangle is your hypotenuse, right? This is your hypotenuse. Now, this legs, okay, opposite of your angle is the opposite side, and the other side is the adjacent side. Okay, so that's how we describe the sides of the right triangle. Now, the opposite side, since this is in vertical manner, yan ay yung magiging v sub iy natin. So that is your vertical velocity. This one, this adjacent side, now is your v sub ix, your horizontal velocity. Okay? Now, if we're going to get an equation here, and if we're looking for a formula for v sub iy, okay, since given naman ang angle at given naman always ang inyong v sub I, we're using this as your values, not to solve v sub iy. So what trigonometric function are we going to use, no? If we're after getting the v sub iy. So this is opposite, and we have value for your hypotenuse. Yun naman yung sinabi ni sir. So v sub iy, okay, so kapag sinabi kasi natin class na so, ibig sabihin nito sine theta is equal to opposite over hypotenuse. Okay, your ka, that is your cosine theta, is equal to adjacent over hypotenuse. Okay, your toa, that is your tangent theta, or tan theta, is equal to your opposite over adjacent. Okay? Now, in this case, since may given tayo, after tayo sa v sub iy, yan yung opposite nyo. May given na angle, may given na v sub I, your hypotenuse. So, if we're after with v sub iy, sine theta is equal to v sub iy over your hypotenuse, your v sub I. Okay, so if we're going to simplify this one, cross multiplication, okay, what will happen here is that, okay, so this becomes v sub iy is equal to your v sub I Okay, sine theta. So this is now your formula in getting the value of your v sub iy. Okay, so sine theta kasi opposite over hypotenuse. May given tayo ni na angle at may given tayong hypotenuse. Now, if we're looking for the v sub ix, ang ginagamit natin dyan ay yung ka kasi adjacent over hypotenuse. So, ang mangyayari dyan, that becomes cos theta, okay, is equal to adjacent, that is your v sub ix, over your hypotenuse na v sub I. Okay, so cross-multiply para makuha natin yung equation for v sub ix. Magiging v sub ix is equal to your v sub I multiply to cos theta. Okay, so this is now your equation. Okay, kaya kung babalikan natin class, this particular table, okay, this is the formula for getting the v sub iy and this is the formula for getting the v sub ix. Parehas lang, no? So, saan to nagmula? From this trigonometric functions. Okay, na so at ka. Now, the TOA, the tangent, sometimes wala tayong value for your angle and there's value for your vertical component and the horizontal component velocities. You can use this one. Okay? So, you can further work with this, okay, in order to get your angle. Okay? So, this is how I show you, okay, the equations for v sub I and v sub iy and v sub ix. Sige, move tayo sa sample problems. So, number 1, we have here a cannonball is fired from ground level at an angle of 60 degrees with the ground at a speed of 72 meter per second. So, what are the vertical and horizontal components of the velocity at the time of launch? So, if we're going to illustrate this one, so the arrow is the cannonball. So, the initial velocity is 72 meter per second. So, this is your v sub I. Okay. Launch at a certain angle, which is 60 degrees. Okay. Using Gressa method, our given is your angle, the theta 60 degrees, and 60 degrees, and your v sub I, the v sub I, which is your 72 meters per second. Okay, so we are asked to compute for the vertical and the horizontal components of velocity. So your vertical is your v sub iy and your v sub ix. Okay, so we're going to solve for that. So our equation as presented earlier for v sub iy, okay, we'll be using your v sub iy is equal to v sub I, your v sub I sine theta. Okay, while for your v sub ix is equal to v sub I cos theta. Okay? So, substitute natin ang ating mga given for our solution. V sub iy muna tayo. Is equal to, v sub I natin is 72 meter per second. Multiply to your sine theta, which is 60 degrees. You just simply write here sine 60 degrees. So how can we solve for sine 60 degrees? You just you have to press in your scientific calculator. Okay, press sine. May makikita kayo dyan, sine na key. Okay, sine, press that and then press the numerical value na 60. Okay, and equal sign. Okay, so once you do that, so sine 60, so that is equal to this, the value of sine 60 is 0.8660. Okay, 25403. Okay, so that is the value of your sine. Do not round off this value, no? Sa final answer tayo nagra-round off. And you multiply this to 72 meter per second. So our v sub iy na for our answer is v sub iy is equal to, so multiply that to 72. That gives you, okay, 2 decimal places lang tayo, no? The answer is 62.35. Yung katabi ni 5 ay 3. Okay, so hindi naman natin mara-round off si 5 kasi not greater than 5 or equal to 5. So the unit is meter per second kasi velocity. So this is for v sub iy. We're not yet done kasi we're still looking for v sub ix. Now for solution, v sub ix is equal to v sub I natin na 72 meter per second. Multiply natin sa cos 60 degrees. Okay, so press nyo ulit sa calculator cos. Meron kayo dyan makikita ang key na cos. Then the numerical value na 60. Then equal sign. So cos 60, that gives you 0.5. Okay, so you have to use calculator and multiply that to 72 meter per second. So v sub ix is equal to, so our answer for v sub ix is, so times 72, that gives you 36. Okay, and the unit is meter per second. So this is your horizontal component velocity. Now we're done solving this problem. So that's how we use the trigonometric function, particularly the sine and the cosine. So let's have second problem. Here you kick a soccer ball at an angle of 40 degrees above the ground with a velocity of 20 meters per second. What is the maximum height the soccer ball will reach? So that's the question. Now we're going to illustrate this one. So there's, let's say, a person who kicked this soccer ball at this particular angle. Okay, above the ground, that is 40 degrees. And the speed of the ball, okay, is 20 meters per second. Now using Gressa, okay, our given are the theta, the angle, which is 40 degrees, and the v sub I, which is the 20 meters per second, the initial velocity. What we're after is to solve the maximum height the soccer ball will reach. So maximum height, that is your d sub y, as I discussed earlier, or your h sub max. Okay, so we're going to write here d sub y or h sub max. In order to solve this unknown variable, let's take a look on this table again. Hopefully yun na screenshot niya. So the table shows that in order to get the maximum height, this is the formula that we're going to utilize. Okay, so we're going to write that here again. Okay, so d sub y is equal to your v sub y squared minus v sub iy squared, okay, over 2g. So that's how we solve the d sub y using this equation. But since if we're going to analyze our given, we don't have value for b sub iy, right? We don't have value for this. Okay, but using the concept discussed earlier and from the other video recorded discussions, your v sub y means the final. Automatically, okay, if vertical ang tinitingnan natin, there's no final velocity kasi object stops as it reach the thickest point. So your v sub y here, your final velocity is 0 meter per second. So saan nanggaling to? Sa konsepto and the way we analyze the problem. So v sub iy, so in order to get this, may formula tayo dyan. Okay, so our formula for that is v sub iy is equal to your v sub I sine theta. Okay, so v sub iy is equal to v sub I, which is 20 meter per second, multiply to sine theta, which is your 40 degrees. So again, press on your calculator, sine 40. That gives you, hindi tayo magra-round off muna ha, 0.642787609. Multiply that to your 20 meter per second. Okay, so that gives you your v sub iy 12.86 kasi 12.8557 yan. So round off natin to 2 decimal places, that gives you 12.86 meter per second. So this value is important for us to move forward in this equation. Okay? So hopefully nasusundan si sir. Now for our solution, since meron na tayong value for b sub iy, meron na tayong value for b sub y, substitute natin. d sub y is equal to 0 meter per second, i-square natin yan, minus your v sub iy, this one, i-square din natin yan. Okay, since 0 to, automatically, dito na tayo mag-work. So, 2g, yung gravity natin, always there yan, negative 9.8 meter per second squared. So, 2 times negative 9.8 meter per second squared. So, d sub y is equal to, d na to. So, this gives you negative. So, square natin 12.86. That gives you 165.3796 meter squared second squared. Over, multiply lang din natin tong negative 9.8 kay 2. That gives you negative 19.6 meter per second squared. Cancel similar units. May natirang isang m here. That's the unit for the distance or the height. Okay, so doing the operation involved here, so the answer na for your d sub y, negative 165.3796 over your negative 19.6 will give you, okay, so hopefully you're working with your calculator, divide to your negative 19.6. So, d sub y is round off natin para may 2 decimal places tayo. Yung sa calculator natin, 8.437. So, that becomes 8.44 meters. Kasi ito yung unit na natira. So, this is now our answer. So, this is the highest peak na na-reach ng soccer ball. Okay? If you kick it at 40 degrees having this particular velocity. Okay? So, hopefully, naunawaan on how we solve for this particular problem. Now, moving on to the third problem. Okay? So, again, important itong equations na to. So let's have this third problem. A cannonball is launched at ground level at an angle of 30 degrees above the horizontal with an initial velocity of 26 meters per second. How far does the cannon travel horizontally before it reaches the ground? Sige, illustrate natin. So imagine na lang class that this is a cannonball, yung arrow. So at 30 degrees. Okay, at 30 degrees with this particular velocity of 26 meter per second. So given natin your v sub I na 26 meter per second and your theta na 30 degrees. Okay, since at 30 degrees, right? So since we're looking for how far, so distance yan, kapag tanong how far, travel horizontally. So horizontally, d sub x yun. Or your range. Okay, capital R. Okay, range yan. So that's how we write it or denote it, the range or your d sub x. So if we're going to look on the equation, you would see that if we're going to solve for d sub x, this is the formula. Right? So we're going to copy that. Okay, so our equation is d sub x is equal to v sub I x multiplied to 2. Since sa problem wala tayong value ni v sub I x, kukunin natin yan. Okay, using this equation, v sub I x is equal to v sub I, okay, cos theta. So, given naman yung equation na yan. So, substitute natin 26 meter per second multiplied to cos 30 degrees. I-press natin yung cos sa calculator, then 30 equals sign. Hindi mo na tayo magto 2 decimal places. 0.866025403. Multiply that to 26 meter per second. Okay? So that gives you, your v sub I x now is 22.52 meter per second. Kasi yung katabi ni 51 is 6, kaya na-round off natin. 2 decimal places tayo. Okay? So we're going to use that in order to solve this problem para mag-move forward tayo for this equation. Okay, since sa problem again, if we're going to analyze, wala tayong value ni t. Hindi naman yan problema. We're going to compute for t, for the time. So, balikan natin equation in order for us to solve for the value of t. Okay? So, gagawin natin equation is this one in order to get the time. Okay? But again, the time here is the time that it moves upward. Okay? But remember, in order to get the total time, okay, t up plus t down, that gives you the total time. But this is just for the upward motion. Okay? Pero t up is just equal to t down. So, you just simply multiply it to 2 para makakuha ka ng total time. Okay? Hopefully, nasusundan si sir. So, copy natin yan. Okay? So, in order to solve for time, kasi wala tayo nito, the equation is t is equal to v sub y minus v sub iy, okay, over c. Since wala pa rin naman sa given natin si v sub iy, kukunin din natin siya. Okay? Madali lang naman kasi meron tayong formula for v sub iy. That is v sub I sine theta. Right? Substitute lang. 26 meter per second multiplied to sine 30 degrees. Okay, click lang natin si sine 30. That gives you 0.5. Multiply mo lang yan sa 26 meter per second. That gives you, your v sub iy is 13 meter per second. So, gagamitin natin siya here, knowing na alam na natin na final velocity at vertical component is always 0 meter per second minus 13 meter per second over the gravity na negative 9.8 meter per second squared. Okay? So, 0 minus negative 13 is negative 13. Divide nyo yan sa negative 9.8. Negative 13 divide by negative 9.8. That gives us the answer, which is 1.33. Bakit po 1.33? Ang katabi ni 32 ay si 6, kaya naging 1.33. 2 decimal places. So, cancel similar units here. So, may natirang S. That's the reason why this is 1.33 seconds. This is now the value for your time. But again, this is just for upward motion. Okay? Dahil bumaba naman yung object, yung cannonball, okay, para malaman natin kung gaano yung range niya, point, 'di ba? The point kung saan siya na-launch at saan siya nag-hit, yun yung range natin. That's how we define it. So it moves up and down, okay? So this is just for T up. Now T up, okay, for total time, sabi natin T up plus T down. Or simply, total time, multiply mo yan sa 2 times T. Okay? So, parehas lang naman yan. So, total time is 2 multiplied to 1.33 seconds. Bakit natin ito ulit ginagawa? Kasi, ang nakuha lang natin yung time na mag-up siya. Dapat, ganun din yung mula sa pag-up at sa pag-down. Okay? Kasi, this is for range. Now, multiply that. That gives you total time, which is 2.66 seconds. Okay? Now, this one is the one that we're going to use for this equation. So, for our solution, v sub x is equal to v sub ix. Meron tayo niyan, which is this. 22.52 meter per second multiplied to the time na 2.66 seconds. Okay? Now, for our answer, our d sub x na, multiply lang natin to, cancel similar units. Meter ang unit ng distance. 2 decimal places tayo, 22.52 multiplied to 2.66. That gives you 59.90 meters. So, this is now our answer. This is the range. From the point it was released to the point na na-hit niya ang ground. Okay? So, at 30 degrees, na-reach na ang 59.90 meters. So, in this problem, pinakita lang ni Sir yung flexibility ng pagsosolve natin. Ganun din ang complexity. So, even if dalawa lang ang given based on the problem, and if you're looking to the equation, to solve the unknown, there are values na you have to look for muna to further move forward sa equation na gagamitin. Like with this one, you get the v sub ix, you get the t kasi wala naman yung mga values na yon. But nothing to worry, we can move to that since equations are provided na dun sa table. Okay? Huwag kakalimutan yung mga konseptong tinuro ni Sir kasi sometimes sa problem, hindi naman given yung value ni gravity, yung value ni final velocity, so on and so forth. Okay? Now, to end our discussion for projectile motion, always remember this conceptual notions. First, a projectile is any object upon which the only force is gravity. Second, projectiles travel with a parabolic trajectory due to the influence of gravity. Third, there are no horizontal forces acting upon projectiles and thus no horizontal acceleration. Fourth, the horizontal velocity of a projectile is constant and never-changing in value. Fifth, there is a vertical acceleration caused by gravity. Its value is 9.8 meter per second down, or 9.8 meter per second squared. The vertical velocity of a projectile changes by 9.8 meter per second each second, and the horizontal motion of a projectile is independent of its vertical motion. Kaya kung napapansin nyo, we look on those two dimensions in a separate manner. Okay? And that's end the discussion for projectiles. Hopefully, you learned something and you can work on now on your activities.